All right, guys, back again with another video. This time, transformations. We're going to be talking about vertical flips. Okay, if a graph, the parent function of a graph flips vertically, what that looks like. Okay, so again, just like before, I'm going to show you on Desmos first because that helps to kind of get an introduction type of visual to it, and then we'll do some examples on here. So, Desmos first. All right, guys, back in Desmos, and I just want you to look at what happens with a negative out in front of the x in the equation. Okay, so look, if it's x squared, y equals x squared, that's your standard quadratic parent function. If I make it a negative, it flips it around. Okay, flips it around, specifically flips it across the x-axis. Okay, so it's almost like there's a mirror image across the x-axis. Okay, so if I add a negative in there, it flips it upside down. Okay, that goes for every parent function. Okay, so y equals absolute value of x. Notice this negative is going to go outside, not in the absolute value with the x, but outside of it. Okay, that's what makes this, I call it a vertical flip. Okay, so it's opening upwards, add the negative out in front, opens downwards. Okay, same with square root. Not in the absolute, or not in the square root with the x, but a negative, right, flips it upside down. And then same with cube root. This is going to be an interesting one. Cube root, kind of it's that S shape, and then look what happens here. Negative, kind of, again, it is a vertical flip, but yeah, it just kind of shifts it upside down. Okay. So number one, we got y equals negative square root of x. Okay, y equals negative square root of x. So obviously the parent function, PF, parent function would be a square root. Okay, and so when we know the parent function, again, the right thing to do is to sketch that, like the directions say, so that we can compare it to what the transformation is. And so, right, start at the origin, like we do with all graphs, and then, right, this is the one that's kind of that cannonball shot. So 0, 0, 1, 1, 4, 2, and 9, 3. Again, hopefully you're getting a little bit better at this point at knowing where exactly these points are. But again, you can make a table. If you're slower with that, that's totally fine. All right, so there is our parent function. So negative square root of x, okay, so what happens here is that, right, it basically what happens is, right, for let's just say 4 comma 2. Like, how do we get that point? Well, we'd plug 4 in here, right? And the square root of 4 would be 2. So y equals 2 when x is 4. That's for the parent function. But when we have this negative out in front, basically what happens mathematically is we do the same math. So the square root of 4 is 2. But then it's like there's just that negative kind of added to it. Or again, another way of saying kind of multiplied by negative 1. So basically what happens is all these are like negative. Like they become negative. So 0, 0, if I'm sketching this graph of the actual function here, 0, 0, that point stays the same. But 1, comma, negative 1, right? That's what we mean when we say it flips over the x-axis. 4, comma 2, again, the opposite of that, or the flip version of that, 4, comma, negative 2, right? Square root of 4 is 2, but make it negative, so negative 2, okay? Again, same thing for this one. Our next point we said is 9, okay? So 9, square root of 9 is 3, but make it negative, so negative 3. That'd be right here. And so again, a negative out there, what that does is it just reflects it or flips it over the x-axis, or a vertical flip because it's flipping in the vertical direction. Okay? Domain and range here, what would that be? So for the parent function, they're both x and y are greater than or equal to 0, right? Because it's going in the positive direction for each one. But for this one here, right, we see, okay, think about the x values. Is it going left and right forever? No. But it is going to the right forever, which means for the x values, that'll stay the same. X is greater than or equal to 0, right? All the positive x values will be hit, and 0 will be hit by this line, okay? But then the range, right? Notice for the range, for the y values, up and down. This one is kind of going up forever, so it hit all the positive y values. This one, it's going down forever. Again, very gradually, but it's hitting all the negative y values in 0. Okay, so we would say instead of y is greater than or equal to 0, y is less than or equal to 0. Okay, because y is the highest, that 0 is the highest y value that this line ever hits. Number 2, same thing, except it is negative x cubed. Okay, this would be a cubic graph, okay, and a cubic parent function. So I draw that original. Again, start at the origin, but then I go up 1 over 1. This is that kind of S-shaped looking one. -2, -8 down here, and then negative or +2, +8 up here. Alrighty, so there's the parent function right there, looking good. And then the flipped version of that, this is interesting because, right, it's kind of it'd be hard to flip this, okay? But watch what I do here, okay? Again, it's kind of it's the same math being done, but you just make the number negative or you negate it once you're done, okay? So like this point right here is -2, -8, because when you cube -2, you get -8 as an answer. But then this negative right here negates it again, so it turns -8 into +8. So the flipped version of this, you just take that up here. You just reflect it over the x-axis. So if it's -8 down here, you go to +8. This one is -1 on the y-axis. You make it +1. Okay, so that's what flipping vertically is like. You flip it over the x-axis. 0, 0 still there. This is at +1, so it comes down here to -1, and then +8 becomes -8. So it's just flipping. It's just flipping each of those values, and it's going to look like that. Okay, so that is what negative x cubed graph looks like. It's just, again, flipping all those values. Okay, that's a cool looking graph. Love it. Okay, domain and range real quick. Domain for this one, I'll just do both. They're not going to change. They're both all real numbers. Okay, flipping this vertically does not change that. This will extend forever to the left and to the right, and it will still go up and down forever. So they're both all real numbers. All right, let me erase here, and then we will do 2 more examples. All right, so I've got 3 and 4 up here. Okay, so number 3, looking at this, y equals negative quantity of x minus 4 squared. Okay, so again, first thing we got to do, identify the parent function and then draw that sucker on the graph. Parent function is a quadratic because that's squared. So that is a quadratic graph, and that is a parabola shape, right? So start at the origin, up 1 over 1 in both directions, and then up 4 over 2 in both directions. Very good. Okay, so then the shifts, okay, the transformations. What's going to happen to this? Okay, so 2 things. Again, what we're looking at, like, how is this different from the parent function, which is just the normal x squared, okay? So there are 2 things that are different, okay? There's this negative, again, so that means there's going to be a vertical flip. Again, that's just that flipping over that we've just seen. And then this -4 in the parentheses with the x. Again, when it's in with the x here, that is a horizontal shift, right? H for horizontal. So horizontal shift of, right, if it's -4 in here, again, it's reverse from what you'd think, so it actually means right 4. So let's draw it, okay? So again, first we shift that origin point, okay? We shift that origin point first. So we're here, and then we move over right 4. Again, the vertical flip doesn't change where the origin's going to be. That's just those horizontal and vertical shifts change where the origin is. So we shift this over 1, 2, 3, 4. There's no vertical shifts or translations here, so we're good to just stick with that. That's where my vertex is, or my origin point. And if this negative wasn't here, I would just draw the, again, same parabola shape, the smiley face, and be done. Okay, but this negative out here turns it into a frowny face. Instead of going up 1 and over 1 in both directions, I move down 1 and over 1 in both directions. Again, it's going to be the same shape, like the points are going to be the same distance apart. It's just going to be flipped the other way, okay? And then right these 2 points, it would go up 4 over 2 to both sides, and we're going to go down 4 and over 2 to both sides. There we go. There is my parabola, okay, with a right 4 shift and then a vertical flip, okay? So then again, domain and range of this, okay, the domain, does it extend left and right forever? Yes, it will eventually, right, because this is a parabola and it'll keep getting wider and wider. So all real numbers for the domain. Range, does it go up and down forever? No. So, okay, so where does it stop? Okay, well, it goes here, right, on the y-axis, that'd be 0, and then it goes down forever, right? So if it goes down forever, that means it is going to get all of the negatives and the y values, but the highest y value it ever hits is 0. So you'd say y is less than or equal to 0. Number 4, looking at this guy, y equals the negative cube root of x plus 6. Okay, And notice where that plus 6 is. That plus 6 is not in the radical, okay? So what is that plus 6 telling us? That plus 6 is telling us a vertical, okay? That's a plus k, okay? That's a k value. So that would denote a vertical shift of up 6. But first, parent function. My parent function is a cube root, okay? So let's draw that. Actually, while I have this here, right, my only shifts are going to be this plus 6 vertical shift and then this negative out in front. So that's also a vertical flip. So plus 6 plus a vertical flip, that's what's going to happen. So cube root graph, again, it's very similar to the cube graph that we just did for number 2 before, but it's just more elongated, okay, or pushed on its side. So 0, 0, 1, 1, negative 1, negative 1, same as cubic, but negative 8, negative 2 here, and then positive 8, positive 2 here. That is that cubic or cube root shape. Okay, so then I perform my transformations. So first, again, I shift that origin point. Okay, so I'm going to count up 6. And there's no horizontal shift, so I'm good to just count up 6. 1, 2, 3, 4, 5, 6. And I make my new origin right there. And this one's going to be tricky, okay? Again, what might be helpful here is to just kind of sketch what the original looked like, okay? Because it is going to maintain the original shape. So let me draw these mini points here. Okay, so I'm just counting. Again, it's going to be maintain the same shape. So it's going to be like this negative 1 point. So go down 1 over 1 there, up 1 over 1 there. Okay, and then up 2 over 8, down 2 over 8. Okay, so that's what the original would look like. Okay, but again, with the flip, my points aren't going to be there. Okay, I'm going to negate those. So what's even helpful to do almost is even like pretend that there's like an x-axis here. You can even draw that dotted line if you want to, because what we're going to do is we're going to flip these values, flip these points across that imaginary axis. So like this point right here is not actually going to be there. I'm going to flip it. So it's going to be up here. This point right here, flip over that imaginary axis to here. This point right here. So it's 2 below my imaginary axis. So again, flipping it means going to above my imaginary axis. And then this one is 2 above the imaginary axis, so I go down. So that's what it looks like. That's what it looks like. But again, so drawing, especially as you're first practicing these, drawing that imaginary axis can be super helpful for a flip like this, okay? I erased it and then I forgot to do my domain and range, so let's not forget those. And they're both all real numbers, okay? It's going to extend left and right forever. So that's all real numbers. And then the range, again, it doesn't look like it, but it will extend eventually up and down forever as this expands. So that's all real numbers too. Hope that makes sense to you. Good job. Thanks for following.